Astronomers have confirmed over 5,500 exoplanets so far. Most of them are just rocks or gas balls doing nothing interesting in the dark, but a handful of them should not exist by any model of physics we currently have. And the last one on this list was only discovered recently. And what makes it terrifying isn't what it is. It's what's missing from it entirely. Let's go through 6 of them, starting with the ones you may have heard of and working toward the ones that are significantly harder to explain away. You've probably heard that space is cold, and mostly it is. But HD 189733b is a planet about 64 light-years from Earth that has made it very clear it did not get that memo. HD 189733b is a gas giant slightly larger than Jupiter, orbiting its star so closely that a full year on it lasts just over 2 Earth days. Because it's that close, one side of the planet permanently faces the star, and one side permanently faces away. The dayside temperature sits at around 1,000 degrees Celsius. That alone would be enough, but what makes HD 189733b specifically terrifying is what happens in the atmosphere. The planet's atmosphere contains silicate particles, the same material glass is made from, and because of the extreme temperature difference between the day side and the night side, the atmosphere generates winds of up to 8,700 kilometers per hour. Those winds pick up the silicate particles and carry them around the planet at that speed. It rains glass sideways at 8,700 kilometers per hour. If you were standing on the surface, you wouldn't be burned or frozen or crushed. You would be shredded, slowly and thoroughly, by glass traveling faster than anything on Earth has ever moved at ground level. And it does this continuously, every day, for no audience. Just glass, wind, and heat on a loop forever. If HD 189733b is bad, 55 Cancri E is what happens when a planet decides heat alone isn't enough of a problem and commits fully to the bit. 55 Cancri E is a super Earth, roughly twice the size of our planet, orbiting its star at a distance so close that a full year lasts just 18 hours. 18 hours. By the time you've had a full day's sleep on Earth, an entire year has passed on 55 Cancri A. The surface temperature on the day side sits at around 2,400 degrees Celsius. To put that in perspective, that is hot enough to melt not just rock, but the metals inside rock. The surface of 55 Cancri E is not solid ground. It is an ocean of molten lava, churning constantly, covering what was once a rocky planet entirely. And here is the detail that makes it genuinely unsettling rather than just extremely hot. Early observations suggested the planet may have a carbon-rich interior, leading some scientists to propose that under the right pressure conditions deep inside the planet, carbon could be compressed into diamond. There may be an ocean of lava sitting on top of a layer of compressed diamond thousands of kilometers thick. The most valuable material on Earth is buried under the most hostile surface in the known solar neighborhood, on a planet nobody can ever reach, doing absolutely nothing useful for anyone. WASP 76b sits about 640 light-years from Earth, and it takes everything the previous 2 planets did and makes it personal. Like HD 189733b, WASP 76b is tidally locked, one side always facing its star, one side always facing away. The dayside temperature reaches around 2,400 degrees Celsius, which is hot enough to vaporize iron. And iron does vaporize on the dayside. It lifts off the surface, enters the atmosphere as vapor, and gets carried by the planet's winds toward the cooler night side. On the night side, the temperature drops enough that the iron vapor condenses and falls. It rains iron on WASP 76b, not metaphorically, not as a poetic description of something that resembles iron rain. Actual liquid iron droplets falling from the atmosphere on the night side of the planet every single day on a planet 640 light-years away that has been doing this completely unobserved for billions of years. There is no safe side of WASP 76b. There is the side that melts you and the side that drowns you in liquid iron. That is the entire range of options. TRES 2b is 750 light-years from Earth, and it is, by measurement, the darkest known planet in the universe. It reflects less than 1% of the light that hits it. For comparison, coal, one of the darkest naturally occurring substances on Earth, reflects about 4%. TRES 2b reflects less light than coal. It is darker than any paint ever made, darker than almost anything we have a reference for. Scientists are not entirely sure why. The planet's atmosphere contains light-absorbing chemicals including vaporized sodium, potassium, and titanium oxide, which help explain some of the absorption. But the models don't fully account for how dark it actually is. Something about TRES 2b absorbs light more completely than current atmospheric atmospheric models predict, and nobody has fully explained what that something is. What makes it visually disturbing is what it means in practice. TRES-2b orbits very close to its star, close enough that it is being blasted with enormous amounts of radiation and heat, sitting at around 1,000 degrees Celsius, but almost none of that energy is reflected back. It just absorbs it, all of it. A planet soaking up light and heat and giving back almost nothing. From a distance, even with a star right next to it, it would be nearly impossible to see. It is an enormous, hot, invisible planet, and the reason it absorbs so much is something we still haven't fully solved. Kepler-7b was one of the first exoplanets confirmed by the Kepler Space Telescope, and it is strange in a way that took scientists years to fully process. It is a gas giant roughly 1.5 times the size of Jupiter, but with a density lower than cork, lower than styrofoam, lower than almost any solid or liquid material you can think of. If you could find an ocean large enough, Kepler-7b would float in it. A planet the size of Jupiter, floating. That is what Kepler-7b is. It orbits extremely close to its star and receives enormous amounts of heat and radiation, which has caused its atmosphere to puff outward to an extraordinary size. The planet is essentially being inflated by its star. The longer it stays in its current orbit, the more its atmosphere gets heated, the more it expands. And there is a point at which the planet's own gravity can no longer hold the atmosphere in place. Kepler-7b may be in the process of slowly losing itself. Its own star is inflating it, and the inflation doesn't stop. The outer layers of atmosphere are likely bleeding off into space continuously, and over a long enough timeline, the planet gradually becomes less of a planet and more of a trail of gas following an increasingly exposed core around a star. It is a Jupiter-sized planet that is evaporating, slowly, continuously, and with nothing to stop it. HATP-7b is 1,040 light-years from Earth, and it is the one on this list that NASA itself has described as genuinely difficult to model. It is a gas giant about 1.8 times the size of Jupiter, tidally locked, with a dayside temperature of around 2,860 degrees Celsius, hot enough to vaporize most metals and many minerals. But what makes HATP-7b specifically unusual is its weather. In 2016, NASA scientists analyzing years of brightness data from the Kepler telescope found that the planet's atmosphere wasn't behaving consistently. The winds on HATP-7b don't blow in one direction. They shift. The dominant wind direction on the planet changes over time, reversing and changing speed in patterns that don't match any stable atmospheric model scientists had for a planet in its situation. What this means in practice is that the corundum, the mineral that makes up rubies and sapphires, which vaporizes on the day side and condenses on the night side, is not falling in predictable locations. The clouds of vaporized gemstones that form in HATP-7b's atmosphere are being pushed around by winds that change direction unpredictably, meaning the ruby and sapphire rain that falls on the night side doesn't fall consistently anywhere. It rains rubies and sapphires on HATP-7b in random locations, driven by winds that scientists still cannot fully predict or explain. But the fact that after years of observation, with our best telescopes and models pointed directly at it, it is still not fully behaving the way it should. The universe produced something here that our current understanding of physics cannot completely account for, and there are 5,500 more of these out there that we haven't looked at carefully yet. So that's 6 planets. These are not hypothetical planets. They are not science fiction. They are real, confirmed, observed worlds that exist right now in this galaxy, doing all of this with nobody watching. And there are 5,500 more confirmed exoplanets we haven't covered. Most of them are fine, but if the ratio holds, a few of them are significantly worse than anything on this list. We just haven't looked closely enough yet to find out what they're doing.